Hi, good to see you again. Welcome to Block 3, Developing Number Sense, Lesson 4. I'll share my screen. So, in your previous lesson, you learned how to use mental strategies for addition, subtraction, multiplication, and division of decimal numbers. In today's lesson, you're going to learn how to use mental strategies for fraction calculations. Remember to like the video, share the video with those you think can benefit from it, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you. I would like you to pause video before we start the main lesson and answer these retrieval practice questions in 3 minutes. Assuming you've paused video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. For question 1, you were asked to write the fraction of the diagram that is shaded. So here you can see that we have 7 parts and one part is shaded, so this is 1/7. Here we have 5 equal parts. 3 parts are shaded, so this is 3/5. I'm sure you remember from our previous lesson how to find the range of a list of numbers. You subtract the smallest number from the biggest number. In this case, it is 14 subtract 2, which is 12. Then to work out 40 divided by 100, your answer is 0.4. Okay, let's do some new learning for this lesson. There are 5 fish in a tank. 35 fish in a tank. 1/5 of the fish are blue. Work out the number of blue fish in the tank. Have a think. How would you do this calculation? Well, I'm sure some smart bunch have already figured this out, but let's use our bar model to model this problem because it's going to help us to model even much more challenging problems that you wouldn't otherwise be able to do mentally quickly. So in our mental model, we can say, well, remember the denominator tells us the number of parts things are split into. So in this case, we have 5 equal parts. Now we're told that we're only interested in one lot of those 5 equal parts. So a calculation we could quickly do is 35 divided by 5 mentally, because 35 represents the whole. So in this case, there are 7 fish in each of the 5 parts. Okay, so there are 7 blue fishes. Okay, let's look at another example. If we're asked to work out 5/6 of 48, how would we do this? Have a think. Think about your bar model. So how many equal parts are you splitting things into? I'm sure you've thought about it. It is 6 because we have 6 in the denominator. Now we are interested in 5 lots of those 6 parts. So here is a calculation we could do to find out what each part is worth. We're doing 1/6, so we're dividing by 6, which is 8. So each part contains 8 items. Now, which calculation would you do to find out 5 lots of that? So you could do 8 times 5, or you could do 48 divided by 8, which will also give you 40. Because you're only interested in 5 parts of those lots. It's your turn to practice what you've learned so far. So pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So for question 1, you were simply asked to work out the calculations mentally. Now you're asked to use the bar model to help you. So the bar model is just there to help you. Here we divide by 5. Here we divide by 6. Here we divide by 8. Here we divide by 5. And we multiply by 2. Okay, because one part will be 60 divided by 5, which is 12, but we have 2 lots of that, which we're interested in. Here we divide by 10, and then we multiply by 7. And those should be your answers. Pause the video and answer questions 2 and 3 in 2 minutes. Assuming you've paused the video and you've answered questions 2 and 3, here are the answers. Let's discuss them. So for question 2, you were asked to work out the amounts. Half of 10 is to divide by 2, that's 5. Here you divide by 4. To divide by 4 means you halve and you halve again. So half of 10 is £5, and half of £5 is £2.50. Here you divide by 8. To divide by 8 is to halve again, and to halve again. Okay, so it's a bit like halving £2.50 again, so that would be £1.25. For question 3, you were asked to show 2 different methods you could use to work out this calculation. Now, here are different methods you could do. You could do 1/8 of 40, which is £5, and then you multiply by 7. You could also do 1/8 of 40, and then you subtract 5, that amount, from 40, which will give you 35. So these are different methods that you could use. All right, let's do some new learning. And this is where using the bar model can become very useful in handling some difficult calculations, even when we have to do these mentally. So a quarter of the students in a class wear glasses. 7 students in the class wear glasses. So if we model this mentally, we'll say, well, there are going to be 4 equal parts, and one of those parts has to be 7. So we're being asked how many students are in the class altogether. So if you have 4 equal parts, so doing this mentally, and one of those parts is 7, then it means all of those parts have to be 7. So it's just like doing 7 times 4, which will be 28. So mentally, you could have done this even before writing your calculation, but this is how it could be represented as a bar model. So you can see how thinking about it, in terms of a model and as a bar model can help you to do this calculation. So let's look at another one. 3/5 of the houses on a street have 2 bedrooms. Well, there are 18 2-bedroom houses on the street. We're being asked how many houses are on the street. Well, before we even present the bar model, when we think about it, we'll say, well, we have 3/5. The denominator tells us the number of parts things are split into. So it means we're going to have 5 equal parts in our bar model. Well, out of those 5 equal parts, we're interested in 3 because we're told 3/5 of the houses on the street are 2 bedrooms. But these 3 parts is represented by 18. So what is in each of the part is the calculation would be 18 divided by 3, which is 6. So you're thinking, interesting. So it means each of the boxes has to be 6, and we have 5 lots of them. So we just do 6 times 5, which is 30. But here it is when we represent it as a bar model. Okay, you could have done this mentally a long time ago. So you do 18 divided by 6. Each part contains 6, so you fill the other boxes, and we have 5 lots of them, so your answer is 30. We can also think about our fraction wall or our mental method for doing fraction calculations. So if you're told to add half to 3/10, what do you think this will be? Well, if you think about it, this is the same thing as looking at this calculation, looking at your fraction wall. A half stopped at exactly where the 10th is. So if you look at adding a half to where we stopped at and 3/10, you can see that altogether we have 8/10. Another way of thinking about it is to say Well, you're adding 3/10 and you're adding a half. What is the equivalent of a half in tenths? That is 5/10. All right, that is another way of thinking about it. So 5/10 and 3/10 will be 8/10. Look at this one. You can use the same idea here. You can say, well, you want to add 1/5 to 7/10. What is the equivalent of the fifth, 1/5 to the tenth? The equivalent of 1/5 to the tenth is 2/10. So when you add them, you're going to have 9/10. And that should be your answer. And you can see it here on the fraction wall. So 1/5 plus 7/10. You can see that you stopped right here. So you have 9/10. Okay, it's now time for you to pause the video and practice what you've learned. So pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for question 4, you were asked, work out these problems mentally. Here is a number card, A. 2/3 of A is 6. What is half of A? And that's the answer. It's 4.5. One way of thinking about it is just thinking about your bar model. So you have 2/3. Things will be split into 3 parts. And then if things are split into 3 parts, so let me write, because the denominator, so mentally you say, well, I'm going to split things into 3 equal parts. 2/3 of that is 6. So it means 2 parts of this represent 6. So if you divide the 6 into 2 parts, it means that's 3, and that's 3, and that's 3. So you know straight away that you're dealing with 9 items. But you're being asked what is half of that. Half of 9 is 4.5. Okay, altogether it's 9. So half of 9 is 4.5. Here you ask, here are 2 more number cards, so B and C. 1/4 of B is 10. So again, you know that you've split things into 4 equal parts. That's the denominator telling you how many parts you split things into. You're told that 1/4 of that is 10. And then you're being asked 3/5 of C is 9. So again, you know that you're splitting things into 5 equal parts. Okay, 3 of those lots is 9. So 3 lots of that is 9. You ask, what is the difference between B and C? Well, you've been told that 1/5 of B is 10. Now, if, 1/4 of B is 10. So it means you have 10 things that have been split into, 4 equal parts. Now, if you to have 10 divided by 4 is to halve and to halve again. So half of 10 is 5 and half of 5 is 2.5. So each of these boxes contain 2.5 each. Okay? No, sorry. 1/4 of B is 10. So sorry, each of these is 10. Sorry, that's my mistake. So each of these is 10. So it means the whole lot. So because you've been told 1/4 of B is 10. So one lot of this is 10. So it means the whole lot is 40. So the whole lot of B is 40. And then you're told that 3/5 of C is 9. So here, 3 lots of this is 9. So it means you have 3 in each of them. Okay? Which means 3 times 5 should be 15. All right? So if you're being asked what's the difference between B and C, it's like saying 40 minus 15, which is 25. Here you ask what is the range of A, B, and C. So the range is to take the smallest one from the largest one. So we have 9 being the smallest and we have 40 being the largest. So 40 minus 9 is 31. Let's look at question 5 and 6. So here Annie has a real discount card. The price of a ticket from Leeds to London is £39. Annie uses her discount card. She's charged £26. Annie thinks she could have been charged £13. What mistake has Annie made? So pause this video and answer questions 5 and 6 in 3 minutes. Assuming you've paused the video and you've answered questions 5 and 6, here are the answers. Let's discuss them. So for question 5, she had worked out 1/3 of the ticket price, not 1/3 off the ticket price. So remember, what Annie is given to work out is she has the student rail card, which is 1/3 off all tickets. So Annie has a rail discount card. The price of the ticket from Leeds is £39. Annie uses her discount card. She's charged £26. Annie thinks she could have been charged £13. So the mistake she made is Annie could have worked out 1/3 of £39, which is £13, and this is what she has off. Off means to take away. So what she is charged is 39 minus 13. That is what Annie is required to pay. That's why she's charged £26. But Annie is thinking that it means 1/3 off. These are two different things. 1/3 of the ticket. No, this means 1/3 off, taken away from the actual amount of the ticket price. And here is the answer for question 6. So for question 6, just a minute. So for question 6, you were asked, in a sale, there is 1/5 off all clothing. And here we have it. How much do each of these items cost in the sale? So we'll do 1/5, okay, of the price. So 1/5 of 35 will be £7. So we'll do 35 minus £7, which will be £28 in the sale. And then here you ask the t-shirt, so 1/5 of £6. 1/5 is to of £6. That will be £1. So we do 1/5 of £6. So when we do that, we subtract the 1/5 of the £6 from this from £6. That will be £4.80 in the sale. Pause video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered question 7, here is the answer. Let's discuss them. So here you ask that half of a number is 36. So remember, the denominator tells us the number of parts we split into. So half of the number is 36. It means here is 36. So it means the whole lot is 72, because 36 has to be in all the boxes. So you have 72. And then you're being asked for the whole. What is a quarter of the number? A quarter means to halve and to halve again. So half of 72 is 36, and half of 36 is 18. Okay, so it's to halve and to halve again. Here you are asked to add the fractions mentally. You can use the fraction wall to help you. So if you add the fractions mentally, pause the video and answer this question in 2 minutes. Assuming you've paused the video and you've answered the question, here are the answers. So if you add these mentally, these will be your answers. Pause video and answer question 9 and 10 in 2 minutes. Or you can take longer, you can take 3 or 4 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for question 9, you were asked to work out the calculations in your head. So 1/5 plus 1/10 is 3/10. How do we know? 1/5 is the same thing as 2/10. So you can simply just add these. 2/5 is the same thing as 4/10. So that would be 7/10. Okay, remember when you add, when the denominators are the same, you can simply just add the numerators. 1/5 is the same thing as 2/10. So 7 minus 2 is, 7 minus 2 will be 5/10, of which if you halve it, if you simplify it, it will be half. And then here you have 10/10. This is 10 over 10 minus, this is 2/10, which is 8/10. And then 8/10 minus that, 1/10, that will be 7/10. And then here you're asked to work out this calculation. So this is to divide by 10, which is 75. This is to divide by 10, which is £7.50. This is to divide by 10, which is 75p. This is to divide by 10, which is 7.5 pence. And then this is to divide by 100, which is 6 kilograms. This is to divide by 100, which is 0.6. And this is to divide by 100, which is 0.06. And that brings us to the end of our lesson. So in this lesson, you have learned how to use mental arithmetic strategies to answer questions involving fractions. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.